Thank you all for joining me today. My name is Barazida, and today we're going to talk about how to utilize or unlock the full potential of Jupyter Notebooks and use them in production. So let's start talking about Jupyter Notebooks. Jupyter Notebooks have revolutionized how we build machine learning projects, becoming the de facto standard tool for data scientists. To give you a sense of its impact, Jupyter was awarded the 2017 ACM Software Award System, a prestige honor it shares with Java, Unix, and the web. However, using it to build ML projects and application for production has introduced challenges never encountered before. The new and undefined format, structure, and workflow revealed blind spots that made its usage in production environment an uphill battle. And in our session today, I will share 7 best practices that will help you reduce the time between the initial prototyping using notebooks to deploying them to production. And we're going to use it with various MLOps tools and techniques. And a few words about me. I'm Barazida, and thank you all for joining me today. My background combines structure analysis, computer vision engineering, and MLOps research. I lead the MLOps and outreach team at Barazida, which in one line is the data for machine learning, so a centralized place to host and manage your project, including your code, your data, your models, experiments, and so on. And my team is researching and implementing MLOps solutions and workflows for collaborating on ML project. And this session aims to bring you the essence of what we've learned over the years and about how to use Jupyter Notebooks in a production environment. And so far, the hypothesis that had the highest statistical significance is that the best way to get data scientist attention is by using 3 phrases: notebook, production, and MLOps. And today we're going to have them all. So let's start with the dark side of notebooks, and from there move towards the light. Hopefully, it's not going to be a train that is heading directly to our direction. So the dark side of notebooks. With notebooks, we can run out-of-order code and edit the cells after they have already been ran once. This is a huge disadvantage for reproducibility and makes us put a lot of effort into tracking the kernel state when executing an experiment. Behind the scenes, Jupyter Notebooks are basically a very large JSON files that can't easily be diffed by Git, which makes it very hard to review. And last but not least, the code hosted in our Jupyter Notebooks is not callable outside the notebook, which makes it very hard for testing and reusing. So why do we even use Jupyter Notebooks? Let's just throw them out of the window and go back to the good old IDE. Well, notebooks are a great tool, after all, that gives us superhuman abilities. They give us an interactive way to work with our code. They have built-in visualizations, and we can see the results next to the code that ran them. And this is also a benefit for communicating our work to our colleagues or to our not-so-technical stakeholders that just want to see graphs. And all of this means that Jupyter Notebooks are a very good tool for quick prototyping. And now that we agree that Jupyter Notebooks are a good tool that we can make benefit from, let's see how we can make it more efficient and use it more efficiently and overcome their drawbacks. So to do so, we conducted a user research at Barazida, interviewing hundreds of data scientists, MLOps engineers, VPs, CTOs, and found that when using Jupyter Notebooks and following 7 simple principles, you can dramatically improve your productivity, scalability, and reproducibility, which is a big factor in ML projects. And what we'd like to do is first host our code in modules outside of our Jupyter Notebook, version everything, have peer review when using Jupyter Notebooks, track experiments, use task-oriented notebooks, track environment settings, and use scripts for training and deployment. And this list might sound a bit ambiguous, so let's see how it works in practice and take a common scenario as our use case. And in our use case, our team lead just got on the phone with the CEO, and there's a new project in the funnel, Save the Planet. Surprisingly, the CEO wants it in production by end of week because it's a freaking game changer. Yeah, this is very new. So you roll up your sleeves, you put on your headset, you find the perfect jam for this task, you open your desktop, and you're gonna get some coffee. No, I'm kidding. You're gonna download the dataset to your local machine, open a new notebook, and start exploring your data. Okay, but hold your horses, cowboy. This is not your first rodeo. You've already created a one-of-a-kind, never heard of data analysis plots. But where are they? So you start firing up old notebooks, scrolling through dozens of cells and outputs, looking into hundreds of code lines just to find that one function that you're looking for. But although witnessing the outstanding work that we did a few months back, it's highly time consuming. And we want an easy way to search for the pieces of code that we need. And this, among other things or other reasons, is a very good reason to move our code into modules. And what do I mean by that? After getting our initial piece of code to do what it was designed to do, we refactor it into a Python function that doesn't rely on any global variable and takes everything as an argument. So it's going to look something like this, where we have a plot of global warming distribution. And now we're going to take this function and convert it into a module that doesn't rely on any global variable. And we're going to store this function in a Python script outside of the notebook. And then we're going to import it back to our notebook and use it. And when we're going to build our project this way, and I think this is the most significant piece of advice that I can give you, because this is going to dramatically improve your workflow and your efficiency. We're going to unlock we're going to unlock a world of opportunities. So first and foremost, we can be able to use static code analysis tools to flag programming errors and bugs. We're going to be able to run unit tests on the functions to make sure that we don't fail in production. And we're going to stay dry, meaning we're not going to repeat ourselves. We can now easily use pieces of code in this notebook or in any other notebooks that we're going to open in this project or other projects. And this is a good time to take a sip of water. So now that we can move faster without breaking anything, sorry, Mark, we can now start exploring our data. But what should we do when we're reaching a good results, or better yet, a dead end? So should we just copy cells to the bottom of the notebook just to make sure that we don't lose them? Or should we Stone Age version our notebooks by copying and pasting it and giving it a unique name? Version 1, version 2, the nicest plot, etc. Only if there was a magical tool that enables version control with the power of going back in time. Oh, right, we have Git. So versioning our notebook with Git gives us once again, superhuman abilities. So we can work in an isolated environment, recover our work, use CI/CD for automations, and the list just goes on and on. But aren't we neglecting something here? Remember, we're working on a data science project. And in our project, we don't only need to version our code, we also need to version our data, our models, and our pipelines, which in most cases, the version of the known code components is going to become the focal point of our experiment. And therefore, we want to be able to version them and also retrieve them easily. So for that, many tools emerge in recent years for data and pipeline versioning that are oriented towards different tasks and use cases or type of data set. So I would recommend to research for the tool that best fits your needs. We have DBC, Pachyderm, GitLFS, Delta Lake, LakeFS, and the list just goes on and on. But once we're going to use those tools that are oriented towards our data, towards our models, towards our pipeline to version them, we'll be able to avoid ad hoc versioning and make sure that all of our project is encapsulated. We'll also be able to share versions of our code and modules within the team easily without making copies or sending links to our bucket or our Google Drive or whatever. And most importantly, we'll be able to reproduce our results with a click of a button. So we broke down, explored, and tested our data to create the Mona Lisa of reports. Really, it's a thing of beauty. So we feel comfortable to start processing it. But what if we missed something? What if there's a hidden bias in our work, or our hypothesis isn't supported by the data? Our work should be passed under the magnifying glass of our colleagues, and this is an important step that in most cases is overlooked. We'd like to use reviewing tools that enable us cell and output diffing and communicating with context. And at DAGZA, we're using NBDime under the hood to compare notebooks, and we developed our own mechanism for cell commenting. So in this case, you can click on a cell, add a comment, and then in the code review or the pull request, the person who opened it will be able to get your review very easily without taking screenshots or moving to Slack or any other third-party platform for communicating. I know that GitHub is using Review NB, and there's tons of different tools and plugins for different notebooks. But by using that, we'll be able to review our work. We'll be able to reduce the bias in our work, and once again, we'll be able to find bugs easily. And this is a very important step before moving to production. So we have another set of eyes looking on our code. Another sip of water. Cool, so we're 3 days into the project and we haven't run a single cell that contains fit. We want to train a model and we want to do it now. But before we do that, keep in mind that we're conducting a research here. This is not a software development project. Experimenting without logging the parameters, the results, is basically meaningless because we can't really compare it apples to apples once we're gonna reach to a good result. So we need to keep track of everything that we're doing. And for that, like with large file versioning, many tools emerge in recent years for experiment tracking. And in this case, I think that it doesn't really matter with which hammer you choose to hit the nail, as long as you punch it through. And by using this hammer, we'll be able to build our knowledge base as we go. We'll be able to reproduce our results and experiments to some extent because we're only logging the hyperparameters and the results. So this is the information that we'll be able to retrieve back. And also, once again, we'll be able to avoid manual recording using spreadsheets or whatnot. And we're going to build proper workflows, or this is going to be a guardrail for our team to use all together in the same tool. And now the deadline is closing in, and you're finding yourself going back and forth between processing and modeling, trying to process the data differently, maybe retag it, re-annotate it, and then run the training again. And you start to feeling the heat from your boss to the point where she decides to add 2 more team members to the task. But now what? How can we collaborate together? We're gonna all work on a giant notebook. Okay, so Dean, you're gonna take cells 1 to 29, Guy is gonna take cells 30 to 50, and I'm gonna work on cells 60 and above. But wait, please don't run cell 55 because it takes 4 hours to load. This doesn't make sense, right? So we don't want to work this way because it's most likely going to result in stepping on each other's toes. We'd like to use a designated notebook per task from the get-go. So for every task, let's say for processing, for EDA, for modeling, etc., each task is going to get its own designated notebook, and we're going to be able to produce at the end a report per step. So if a peer would like to review your work, they will be able to just go to the notebook and see the results of the EDA, pre-processing, modeling, etc. And by using a designated notebook per task, we'll be able to scale up or down the number of women or manpower on the task. It's going to make our notebook easier to review and maintain because they're going to be shorter and task-oriented. And our project is going to have a clear structure because each step is going to get a designated notebook. Awesome. So we're 6 hours before the deadline, and we have one last training that we need to run. But the person in charge of modeling just called in sick. My God, I just wish this week is going to be over with. So you connect to your favorite cloud provider, which there is no such thing. You fire a monster machine, pull the latest version of the notebook, and hit run all sales. Okay, pray with me, pray with me. We're gonna hit it, we're gonna hit it, and train. What? Error retrieving driver version, kernel reported driver version not implemented. Not implemented. What now? So we're getting errors because our version of TensorFlow doesn't support this driver. My God. So notebooks need to be reproducible in the sense was that anyone on the team should be able to take your notebook and rerun it in the same using the same input and get the same output. And for that, we should determine and recreate the environment required for the notebook to be executed. And in other words, requirements.txt. But I highly recommend not stopping there and containerizing your environment to ensure that it's isolated and doesn't require any OS level dependencies. And by using that, we'll be able to we'll unlock reproducibility and enable to share our work with anyone. Anyone will be able to pick up our work from where we left it. So it can be our team, a different team member, ourselves in 6 months trying to debug our model, or handling the project to our peers or to the MLOps team that is going to try to deploy the model to production. Water is important. So please, okay, yeah, this is a good connection. So please don't deploy your model to production this way. So by using or deploying your models to production or deploying the notebook itself okay, yeah, I kind of lost it, but I'm gonna cycle back because this was a good meme that hit me off. So basically the bridge here is we're gonna want to deploy our notebook to production. And I highly recommend not doing that. Do not deploy your model to production. There are so many drawbacks when using notebooks in production that the list is just too big to handle. So there are no proper or very well established CI/CD tools that are widely used in the industry. Also, we're gonna need to make a lot of cleaning up and packaging of our notebooks before we're gonna use them in production because they're probably gonna be too heavy with different plots and yada yada yada. And also, notebooks are not that good of a team player. They're not. You can't really use them very easily with other tools, especially with CI/CD tools. So what I recommend is when we're going to move our code into modules and we're going to have our project ready to deployment, then create a main script and use this main script for inference and for deployment. And this leads us to one last principle, is to use scripts in production, which is the industry standard and much more easier to maintain, debug, and reduce the downtime. Scripts are better when we're working at scale and we want to scale up or down, and they can handle heavy loads. And this is also the beautiful part of it. We'll be able to move much faster to production because we already have all of our heavy code in Python scripts, and all we need to do is build our main script, reutilize the pre-processing modules, and import them into our main function, and then deploy this to production. So we don't need to now scatter around for notebooks, copying, pasting code, and trying to figure out what's happening. We can just use our code as we used it in the research phase. Awesome. So we've reached to the end of this session, and I want to circle back and touch upon every principle that we talked about. I feel like the most important one is to host our code in modules and not in our notebooks. So taking our piece of code once it's ready, put it in Python script as a module that doesn't rely on any global variable and take everything as input. And then we'll be able to also use this piece of code when we're deploying to production. have version everything. So not only our notebooks and code, but also our data, our models, our experiments, basically everything. Have peer review, and to have peer review, we also need to use some tools that provide us the ability to review our notebooks and communicate over them. We'd like to track experiments with tools like MLflow, weights and biases, ClearML, etc. We want to use task-oriented notebooks, so break down the spaghetti notebook that is very, very long for the project and have task-oriented notebooks. We want to track the environment setting, and then when deploying, only using scripts for training and deploying. This is it. I want to thank you all for joining me today. It was lovely, and also being the opening session of PyData Global is amazing. I want to thank the PyData Global team for having me today. I welcome you to ping me on Twitter or LinkedIn, or also follow me there, or DAGSUP. And I'd love to learn about your use cases. So if you have any questions, thoughts, ideas on how we can improve this flow, I'd love to learn also from you. So please feel free to ping me and connect, and I'd love to chat. And by that, I think we're ready to move to the Q&A session. So I'm gonna stop presenting, and I'm gonna open the stage for Q&A. What about data / workflow managers like SnakeMake? Tests, I'm not really sure what you mean by that. Is it for data versioning or for pipelines? Can you please elaborate, maybe on the chat? Or open your mic. I'm kind of lost here. Help. Okay, so let's move to the next question, or maybe I'm going to take it from the chat myself. Regarding peer review, we use Bitbucket for versioning Jupyter Notebooks. So what would you recommend? So if you're using Bitbucket, I'm not really sure if they support notebook diffing. So what you can do is either take some open source tool that you can run locally and then use it for diffing. Also the tools that we're using, so NBDime, what we're using at DAGSUP under the hood, is basically can be used on your local machine, and diff versions based on either git commit or giving the path to different notebooks. Or if you want, you can also connect your Bitbucket repo to DAGSUP and then see the notebooks there. Once you're going to connect it, you're going to be able to still use Bitbucket and not leave your Git repo from there, but also use all the tricks and hacks that we have in DAGSUP for data versioning, notebook diffing, experiment tracking, etc. So you can check out NBDime, Notebook Diff, and also DAGSUP if you want to just connect it, plug and play, see how it works for you. And then if you want to use it locally or with DAGSUP, you're more than welcome. It's in the free version, just it's in the community tier. I'm not trying to do anything sketchy here. Next question. We're ready. We have 3 more minutes. I am at the verge of exploration done in several notebooks and having nothing modularized yet. How do I get my stakeholders to understand the work needed for all the tech debt? So if I understand correctly, most of the work is done on experimenting and nothing was modularized. So you didn't move all the code outside of the notebook yet. So it's very hard to, there is a big technical depth there, and converting from notebook to scripts when you're going to reach the point where you're trying to deploy to production is going to be a lot of headache. And also going to be kind of a headache when you're going to try to reproduce results now. So maybe you can show it to them now that you're trying to reproduce your results from, I don't know, a week ago, and see if you will be able to reproduce it. It's going to probably be very hard to do so if you made a lot of changes to your code. And this can be a very good argument into moving your code into modules and be able to diff them easily and see what changes were done to the code and revert back very easily. Also run tests on your code, which now is pretty much undoable, but if you're going to move it into modules, it's going to be easier. Or if you want to, you can always like try to build a deployment pipeline yourself, like use a Streamlit app or whatever to deploy your model and see how hard it is going to be to do that. And this can be also a very good argument to show what it means to move to production and have everything in notebooks and what is the technical depth there. And it's going to take a lot of time to do so. So this, I see a question from the audience. So moving code to modules forces a kernel restart to reload, externalized code. So there is a good solution. There is a good library that enables to do so. Oh, I see that codes send it. I want to open it while we can do it. So basically, you are able to do so. There is a hack for it. I think what codes sent here is the auto reload one, which enables that without turning down or restarting your kernel. But there are solutions for that. You are correct. It was true for like 4 years ago, but now you are able to reload external code. Another question. The moment you move a function outside of the notebooks, you lose some of the interactivity because to edit it, you have to reload the. Oh, we just answered it. So there's a good solution for that. So for reloading, if you're hearing us and you can't see the chat, so auto reload is a Python package that you can use. So search for auto reload in PyPy, and you'll be able to use it. Yeah, so I'm getting a ping that we need to wrap it up. So I want to thank everyone for joining us today. If you have any further questions or you want to ask anything or give me any new ideas on how we can improve this workflow, or if you have your own solutions that you're using to move from the research stage to production, I'd love to hear about it. Let's connect on LinkedIn or on Twitter. I wish you all the best. And to see you in the next PyData Global 2024. Shout out to DexUp and for everyone, and see you. Bye-bye.